this video will explain the concept of a standard form contradiction, or as we will call it, an SFC. So contradictions are logical statements that are always false, just by virtue of their logical structure. So, for example, the formula P double arrow not P. That is always false, because if P is true, well, then not P is false, so we'll have a true and a false on either side of the biconditional, so the biconditional will be false. On the other hand, if P is false, well, then not P will be true, so we'll still have false and true on one side, on each side of the biconditional. So whether P is true or P is false, the formula P double arrow not P will always be false. Likewise, the formula it is false that P or not P is always false. So the formula P or not P is a different kind of formula. It's what's called a tautology. It's a statement that's always true. So if P is true, well then P or not P will be true because of the P being true. And if P is false, well then not P will be true. So P or not P will still be true. So P or not P is always true. But if we negate that, the negation of that will always be false, because when you negate a formula, it has the opposite truth value of the unnegated formula. Another example of a contradiction is the formula P and not P. So that if P is true, well, not P will be false, so P and not P will be false. And if P is false, well then not P and not P will be false because of that. So this last contradiction is called a standard form contradiction, or as we will call it, an SFC. So any formula and its negation. So if we had, so it could be A and not A, or it could be P or Q, and it's false that P or Q. Any formula and its negation. And the standard way we will write that is we will always put the unnegated formula on as the left conjunct and the negated formula as the right conjunct. And that's just the convention. So that's what it means for a contradiction to be a standard form contradiction. So the other statements, the P or not P, and the it's false that P or not P, those are also contradictions, but they're not standard form contradictions. So whenever we're doing either a dash in or a dash out proof, we're aiming for a standard form contradiction. Once we reach this standard form contradiction, we are then entitled to derive our goal by either dash in or dash out, whichever is relevant for your purposes. So I will explain how that works more in the video that explains the rule of dash in and dash out.